Willow, Google's quantum breakthrough into parallel universes in a way has just made a discovery that defies all logic, understanding, and imagination. Willow, a new computer chip designed by Google's Quantum AI Lab, has opened a door to what was once considered purely theoretical, a parallel universe. Yes, you read that right, parallel universes. What was once relegated to the realms of science fiction, fantasy, and the imagination of the most ambitious physicists, has now stepped into the realm of reality, sending shockwaves through the scientific community. Quantum computing, a field already brimming with mysteries and uncertainties, has just taken a turn that no one saw coming, one that might change the very fabric of reality as we know it. Quantum computing, a leap into the unknown. To understand the gravity of this discovery, we need to first grasp the fundamentals of quantum computing. Unlike traditional computers that use bits, either a 1 or a 0 to represent data, quantum computers process information using quantum bits, or qubits. What makes qubits so extraordinary is their ability to exist in a state of superposition. This means that, rather than being restricted to just 0 or 1, a qubit can exist in a combination of both, enabling quantum computers to perform certain calculations at unimaginable speeds, far beyond the capabilities of classical computers. But there's more. Quantum computers don't just rely on superposition. They also take advantage of a phenomenon called entanglement, where two qubits become linked in such a way that the state of one qubit can instantaneously affect the state of another, regardless of the distance between them. This creates a level of parallelism in computing that could revolutionize fields from artificial intelligence to cryptography to complex simulations. Quantum computers, powered by these mysterious phenomena, can tackle problems that were previously unsolvable by any classical machine. Tapping into parallel universes, an unexpected twist, and yet, this very complexity and reliance on the unpredictable nature of quantum mechanics have now opened a door to something entirely unexpected. As scientists pushed the boundaries of quantum computing, they began to realize that the information quantum computers are processing may not just be limited to our universe. In fact, it seems that these quantum systems could be accessing alternate realities, parallel universes. It sounds like the plot of a sci-fi movie, doesn't it? Yet, the evidence emerging from Google's Quantum AI Lab suggests that these parallel universes may not just be theoretical after all. They might actually exist, and they might just be within our reach. This breakthrough came when Google's engineers were testing their Sycamore quantum processor, attempting to measure how qubits interacted with one another. During their experiment, they observed something truly bizarre. Instead of behaving in predictable ways, the qubits were forming patterns that seemed to come from entirely different sources, sources that couldn't be explained by the laws of physics in our own universe. This was no glitch in the system. In fact, what Google's engineers accidentally stumbled upon may have revealed something profound, a link between our universe and parallel realities. What happens when qubits tap into other realities? To put this into simpler terms, imagine you're connecting to a network of computers, expecting to communicate with machines all part of the same system. But instead of receiving data from your expected network, you suddenly get information from computers you weren't even aware existed. This is what happened when Google's quantum processors began pulling data that seemed to come from realities outside of our universe. It was like the qubits had tapped into a multiverse, a network of alternate worlds, each with its own set of laws of physics, histories, and timelines. For years, physicists have speculated about the many worlds interpretation, MWI, of quantum mechanics, which suggests that every time a quantum event occurs, every decision, every possibility, a new parallel universe is created. In these universes, reality unfolds differently based on each choice or potential outcome. What Google's quantum chip may have inadvertently done is find a way to connect to these alternate timelines, bringing them to light in a way we never thought possible. Why should scientists be concerned? Now, you might be asking yourself, if parallel universes really exist, why are scientists so worried? Shouldn't we be excited about the potential breakthroughs this discovery could lead to? Well, excitement is tempered by caution. While the idea of accessing alternate realities is thrilling, the risks are profound, and they could affect far more than just the scientific community. The discovery of these parallel worlds raises existential questions about the very nature of reality. For one, what happens when we interact with another universe? Could it have unforeseen consequences for our own? Could we inadvertently destabilize our reality by bringing something from another dimension into ours? Or worse, could we find ourselves inadvertently changing the course of history, not just in our world, but in others as well? The unpredictability of quantum systems, with their chaotic and uncertain nature, makes it extremely difficult to predict how even the smallest interaction with another universe could ripple through the fabric of our own. The ethical dilemmas of multiversal exploration, but it's not just about the scientific unknowns, there are serious ethical dilemmas that come with this discovery as well. As we venture further into this uncharted territory, we face questions we've never had to confront before. If parallel universes are real, does that mean other versions of ourselves exist there? What rights do beings in these other realities have? And if we begin to manipulate or interact with them, what responsibilities do we have toward them? Moreover, who gets to control access to these parallel worlds? If quantum computers can indeed connect to these alternate realities, what might happen if powerful corporations or governments gain access to this technology? Could the information or resources found in parallel universes be exploited for personal gain, potentially wreaking havoc across dimensions? What could the future hold? This breakthrough also raises the tantalizing, terrifying possibility of multiversal communication. Could we one day be able to communicate with other versions of ourselves, or even entities from alternate realities? If so, what could we learn from them? Could we exchange knowledge, technology, or even ideas with these parallel worlds? The potential for innovation could be limitless, but the dangers are equally significant. The road ahead for quantum computing is one of immense opportunity but also great peril. As we stand at the threshold of a new era, we must proceed with caution and awareness. The possibilities are exciting, perhaps leading to revolutions in medicine, technology, or artificial intelligence. But with these advancements comes the responsibility to understand their implications and the potential risks they carry. Conclusion: a new era of quantum discovery. Google's breakthrough with Willow, the quantum chip that may have discovered a link to parallel universes, has reshaped our understanding of quantum computing and the multiverse. The possibilities are profound, but so too are the risks. As we continue to explore the untapped potential of quantum computing, we must balance the excitement of discovery with the caution necessary to navigate the complexities of a universe that may be far more vast, chaotic, and unpredictable than we ever imagined. Are we ready for the next step in our journey through the quantum world? Or have we opened Pandora's box, one whose consequences we may not fully comprehend until it's too late? As we venture deeper into the unknown, one thing is certain: the future of quantum computing has just begun.